Our goal today is to find x. This equation looks intimidating, and that's because of this fraction. So let's get rid of it. To do that, we multiply both sides by x. We will have x multiplied by x plus 9 over x in the parentheses equals 6x. Let's distribute x on the left side. We will have x squared plus 9, because x in the denominator cancels, equals 6x. Let's subtract 6x from both sides. And now we have x squared minus 6x plus 9 equals 0. And this looks surprisingly familiar. Yes, it is a quadratic, but before we start solving it, let's look at its structure. Notice that our first term is x squared. Well, that's difficult not to notice. Our third term is 3 squared, and our middle term is negative 2 multiplied by 3 multiplied by x. And this matches a familiar pattern, which is a squared minus 2ab plus b squared, which equals a minus b in the parentheses squared. In our case, a is x and b is 3. And now our equation becomes x minus 3 squared equals 0. A square equals 0 only when the quantity being squared equals 0. In our case, it's x minus 3. X minus 3 equals 0. And x equals 3. Well, we add 3 to both sides because we want to do everything by the book. And this is our solution, x equals 3. The fraction at the beginning made the problem look a little bit difficult. And it was just a perfect square in disguise. But what if you didn't see it? Or you just like factoring? Then you can solve the same equation with factoring. Let's do it together. I prefer a diamond method. So let's use this one. In our case, a is actually 1. So we take our a, which is 1, and our c, which is 9, multiply them together, and this number goes to the bottom. 1 multiplied by 9 is 9. Our b, which is negative 6, goes to the top. Now we need to find two numbers, which multiply to 9 and add to negative 6. And these are minus 3 and minus 3. Now we actually need to divide those numbers by our a. Our a is 1, so we can just skip this step. But I will show you just in case when your a is not 1. Now we have x minus 3 multiplied by x minus 3, two repeated factors, equals 0. And by zero product property, x minus 3 equals 0, or x equals 3. The same result. By the way, there is a shortcut to check if your quadratic is a perfect square. To do that, you take your b, which is negative 6, and you divide it by 2. The number you get, negative 3, you square, negative 3 squared. And if the result that you get, which is 9, equals your c, then your quadratic is a perfect square. I want you to notice something. Most of the quadratics produce two solutions. And this one, x minus 3 squared equals 0, produced only one. And the reason is this hidden square. This square will matter again when we look at its graph, and that will be next.